All right, thanks everybody for showing up, and thanks for everybody being on Skype. I assume, based on the thumbs up here, that you guys can all hear me okay. So I'm going to record this on my laptop locally so that it can be available later. I'll put it up on Echo, and we'll jump off from here. So I call this Let's Start Scripting because we've had a lot of presentations from AU. It seemed like a lot of people were really inspired by the different things that they were seeing with Dynamo. There's a huge push from Autodesk to get people involved in what's called visual programming. There's lots of different names for this stuff, so I might inadvertently interchange some names, but just to give you guys some ideas of what those words are. Scripting, right? Because this is all kind of like, it is programming. It's just a visual way to do it, but it's programming nonetheless. So there's scripting, visual programming. Some people call it computational design. There's lots of different things you can call it, and those are pretty much specific subsets of this whole thing. But like I said, those names are pretty interchangeable now. And so I'm saying let's start scripting, but really this is an introduction to visual programming, because what I wanted to do was take inspiration from all the great things that a lot of us saw at Autodesk University and actually try to show you how easy it is to do it so that you can jump in and not be afraid to break anything and actually start making tools that HMC can use. That's what I've been doing, and I feel like it's been really fun. I'll go through kind of what visual programming is actually before I jump into actually doing it so that you guys can see some examples. But my goal here today is for you to walk away and say like, oh man, it's not that hard. It's not that it's not that intimidating anymore, right? So that's really my goal. And then I'm going to show you where the repository is to keep this stuff, and the goal really is to make stuff that's reusable. So as much as we can, a lot of times we're going to be solving unique problems, but a lot of times we're not. We're going to be solving things that can be applied over and over and over again. And that's a big goal of scripting or visual programming, is to automate things, right? Make things reusable and build our tool set here at HMC. So sometimes this is what people, if you do just a Google search for what visual programming could look at, it could look really intimidating. And you can see some of these scripts. I know it's a little washed out here, but they can get immense, but really, most of the time, they're not. Really, most of the time, we're looking at something fairly simple like this. And so, again, I want to take away that kind of shock of looking at that intimidating spaghetti on the wall and turn it into something that actually starts to make sense for just building day-to-day tools. We're going to get into a piece of this one later on today for the hands-on example, all right? So, visual programming, what is it? A lot of people think visual programming is swoopy, crazy, weird shapes, right? This is Zaha Hadid, and yeah, you totally can do this with visual programming. You can also do this with just kind of off-the-shelf modeling, just brute force modeling, right? Which is what lots of people do. What I want to talk about is what visual programming is good at versus what people think it's good at. There's a lot more things in the column of what it is good at. So this is one thing, is making, so yeah, we can make weird shapes, but what visual programming can do is help us make them buildable, fabricatable. So you can see in this image here, there's like different colors applied to the different panels on this crazy shape. So yeah, it's a weird shape, but what this is telling us is we can use algorithms to tell us which of those planes are flat, single curved, and double curved, right? So this is a very visual representation to help us start to break down these complex systems into fabricatable elements, right? So this is an example of that kind of a thing. Making architecture performative. So our regenerative design group is very interested in applying facade systems for daylighting, for glare reduction, and this is just one example where we can analyze the orientation of that face, break it down, apply a panelized system to it that responds to the environment. And that's done algorithmically, right? So you would create a script that would automatically rotate those elements on the facade based on the environment that's going on directly outside that envelope of the building. And that's based on data, right? So we can actually plug in the exact sun location. We can average it out over a year. We can figure out the best place for those panels to be. Model interoperability. This is a huge one, and it's huge for HMC. This is a direction that we're going to be heavily moving into, which is design model on the left, production model on the right. They're exactly the same. We're not rebuilding from scratch when we go from design to production. We want to reuse elements and have them talk to each other so that we don't have to rebuild that building every single time. And the nice thing about this interoperability is by using a visual programming language and specific plugins that other companies have written, they allow them to talk to each other straight across. So we can take elements from one program and plug them right into the other one, and if I update them in one, it updates in the other. So we have this dialogue instead of a complete break between design and production models. So interoperability is a word you'll be hearing a lot out of digital practice, and it goes both ways. It's not just from design to production, but a lot of times you guys know that we're constantly updating models to show in VR for a client, and we all know how heavy Revit models can be. And so this is a two-way communication so that we can just push back out what we need to out of Revit so that we can take that into VR, and we can strip out all the elements that we don't need, and we can use scripts to do that. Data mining and visualization. So this is an example of a dashboard with live model data in it. So something that visual programming is really good at is helping us visualize what's going on inside our building and represent it in a very visual way like this. So you can see here there's different floors of a tower. They're color-coded, and then on the left where it can actually see what program has been assigned to those. So maybe there's residential in blue at the top, and there's mixed use in pink in the middle, and there's retail in aqua at the bottom. And we can easily flip those back and forth between different categories, have dollars assigned to those, and see exactly how much that building pencils out at during the schematic or conceptual design phase. So again, that's all done on the background with probably a very crazy script, but on the front end where we're actually doing the work, because all that's been done, we just get to manipulate objects in the modeling environment, and the dashboard automatically updates live all the time. So very cool thing that you can do with visual programming there. Okay, so this is a fun one I threw in, making bad software tolerable. You guys know how many buttons there are in all these programs, and again, it's just you kind of look at the interface and you think, oh my God, it's like flying a fighter jet versus flying a Cessna, right? So it actually makes it kind of fun to work in, and so I feel like, you know, I'm not a huge fan of working in Revit. I can do whatever I need to do in it, but man, it's not like a joy to use, and so I actually find that working in Dynamo inside of Revit is actually kind of fun, and you're doing a lot of problem solving along the way while you're creating these scripts, and it makes it interesting. So I wanted to throw that one in there. The last one, the one I'm going to focus on today, is automation. So this is something that visual programming is really good at, and this is what I really want to talk about and just show examples of, which is automating tasks that we don't need to keep building over and over and over and over on every single project, right? So with scripting or coding or visual programming or whatever you want to call it, that is what computers are made for, right? Is doing things that we don't need to continually do over and over again. So making reusable tools, automating repetitive tasks, and making assemblies parametric. So as designs change, objects update automatically. Create relationships between things, right? So if my floors get bigger, my columns go with it, all right? Things like that. And of course, there's many more things that visual programming can do. So what I'm going to do now is show you kind of a quick Dynamo example that I built, and this is based on Prospect, which is our software that we use to go and look at our models in VR. And so what I'm going to show you here is just kind of a screenshot of being in a model. And I pulled this image is not from one of our models. This is just from the web because it was faster while I was on vacation last week when I put this together. Is you could go into a model in VR, and one of the more recent updates in Prospect allows you to inspect elements, right? So if you're throwing a Revit model into Prospect, you open it up, you can go in there, and there is a little cube with an eye on it down there in that lower corner right there. Click on that, and then you can just start shooting at an element. It tells you what it is. So it's extracting that BIM data, and you're in VR, and you can say, okay, that's a column. That's it'll tell you whatever metadata has been assigned to that, and that's really what BIM is all about, right? We can do quantity takeoffs. We can see how many cubic yards of concrete there are in the floors, whatever. So what this does is it allows us to inspect different elements, and then we can choose to flag them or not if it's something we want to follow up on later. Or maybe somebody else is in there and they flag a bunch of elements and they say, I want you to take a look at these things. Well, that can get really complicated because we make really big models in BIM, right? So what ends up happening with this really cool thing that Iris added was it spits out this thing on the right here, which is a flagged elements report. All right, so I don't have to remember what all those elements are that I flagged when I'm inside VR. All I need to do is walk around and flag them. All right, so then it spits out this report, which is just a really simple spreadsheet. It's a CSV file. You can open it right up in Excel. I'll show you guys an example here. You hit this export report. It spits out the CSV file, and it looks like this Excel. So simple table. I have one open right here. This is the one that I'm going to show you guys today. So this is the Excel file. I flagged 5 different elements just randomly. All right. It tells you what their family name is. It tells you what their regular name is. It tells you when I flagged them and who flagged them. So depending on the user that's logged in to Prospect at the time, it'll even tell you who did it. So it just kind of builds this quick little text file. And that's what we're looking at inside of Excel. You don't even have to open it in Excel, actually, but just so you know what's in there. You can make sure that the elements that you flagged are actually there if you want. The important bit is these element IDs on the left. So every object that is created inside of Revit gets an element ID assigned to it, and it's just kind of a random jumble of 6 numbers. It's called a hexadecimal. And with that hexadecimal number, everyone gets assigned a unique number. So what do you do with those unique numbers? Well, you could go into Revit and you can select elements by ID. So what happens is you type that number in, that 6-digit number, and it will find it for you inside the model because it knows where every element is, right? Revit is a database. So all it does is look up where that is, and then it shows you in the plan, and you can look through various views and see that element. Okay, or you can run the script that I created in Dynamo and it'll do it all for you. Okay, and this is kind of the idea, is that I'm going to go into a giant model, I'm going to flag 50 items, and I don't want to remember what they are. I want the computer to do that work for me. All right, so what I'm going to do here real quick is just show you a quick demo inside of Revit. This is a Revit, just a sample project, just a house, and you can see that this is a live model, so I'm no longer just doing screenshots here. And what we can do is go into the Manage tab and open up Dynamo. So this is the model that I was in Prospect inspecting. So I was walking around this 2-story house, and I inspected some elements. I generated the report, and now I'm back in Revit. Okay, so I'm back here. I want to see what those elements were that I inspected and flagged. So I opened Dynamo. And Dynamo is a add-in for Revit. It's actually built in now. It used to be a separate installation, but you guys all have this in your Revit installation under the Manage tab. And my computer's probably struggling just because I have so many things open, so give it a moment here to open Dynamo up. Here we go. And you can see Dynamo opens in a separate window. And what I'm going to do now is just open my script. Okay, and I have this script downloaded on my computer. I'll show you where these scripts are located afterward. I open that up, and here's that script in Dynamo. And you can see it's actually not that complicated. There's, I don't know, 1, 2, 3, 4, 5, 6, 7, 8 different nodes. And so all of these nodes are live nodes, and you just click and you drag these little wires between different things, and it hooks them up. And it does matter like what hooks into what, obviously, and we're going to go through one here in a minute that we're going to build from scratch. But what it's doing is it's saying, where's the file? Where's the CSV file? We're going to import that file. We're going to look at the list of items that are in there. And what we're going to do is just isolate all those elements by the ID numbers that are in the CSV file. That's it. Okay? So all I have to actually do is open this script and hit run. That's it. It's basically 2 or 3 buttons. Okay? So again, if I just kind of go back to Revit here, you can see my building is I'm just in a normal 3D view. So whatever view you want to see your elements get isolated in, that's the view you need to have open. And then I'm just going to click run. And boom. It just isolated the elements that I flagged in Prospect. That was it. So now I can go through and say, okay, we can figure out what the issues were with each one of these elements that we needed to go back and revisit, or maybe the person who flagged them comes over and they sit down and we have a conversation about it. Okay? So that's as simple as it actually gets to apply a script to your model. So we download it from Echo, we open it in Dynamo, and we hit run. And that's it. All right? And my goal is to get you guys actually thinking about what kinds of things you want to be able to automate so that you can start building scripts too and contribute to the scripts library. So I'm going to jump out of Revit here. So now that those are isolated, I can close Dynamo, they stay isolated, I could work on them, and then I can obviously just reset my view and go back to my real model. All right? Okay, so back to, let's look at some different, actually I'm just going to jump over here to Grasshopper now. So this is another scripting environment. This one's been around a lot longer than Dynamo. Dynamo's 5 years old or so. Grasshopper is quite a bit older than that. So it actually is quite a bit more full-featured. But Autodesk has enormous amounts of dollars that they can put into developing Dynamo, and they have. And so it's getting good really fast. Grasshopper, on the other hand, is a much smaller development team. And even though it's been around longer, they're working on new versions, but it takes a lot longer for things to happen on the Grasshopper side. But good thing for us is that everything is pretty well figured out already. And there's lots of scripts online that you can download and just start using. All right, so what I wanted to show here was some different files that just give us some ideas on what Grasshopper can do. So I'm gonna open up my practice scripts here that I've been doing on. And I'm going to show you just kind of some different examples of things that I felt like as a designer I wanted to automate so that I didn't have to constantly be rebuilding stuff. All right. So let's see. The first one I'm going to show you guys is, let's just start simple with these walls. Grasshopper does not have a wall tool like Revit does. You draw lines, you extrude them the other direction, you start to get boxes, and you play around with those things as simple box objects or polylines or whatever. It's a lot like AutoCAD. And so what I'm going to show you here is a tool that I wanted to kind of make just so I could quickly visualize walls and, well, in this case, just walls. Okay, so what I've got here is just a simple line diagram. Okay, this could be drawn in Rhino or it could be drawn in AutoCAD, and basically just simple lines that are going to represent walls because, during design, a lot of times we just work with single polylines because we want to figure out area, room adjacencies, things like that. So what I've done with this is I have two different layers, interior walls, exterior walls. I'm gonna go over to Grasshopper and I'm gonna open up my script that I used to create this. All right, so open this up. And what's happening on the Grasshopper side, I'll just kind of pull this out so you guys can see it, is I've actually created some tools. And the cool thing about Grasshopper and Dynamo is you can create a really crazy looking script, but you can consolidate it down into what's called a cluster. And so this cluster is nice because I can share this with other people and they can use this, and it's very simple to use. So you can see, like, I've got this wall maker, I call it, and all I need is the curves. Do I want it to have different thickness, height, and justification? All right. So what I'm going to do here is just turn this on, and you can see here for my interior walls, it just builds that geometry. All right. Well, what's so neat about that is that I can continue to add more walls if I wanted to, as long as I'm drawing on the interior walls layer here. I can go ahead and draw another wall, and you can see it automatically builds a wall out of it. So it's just a simple line. So I can turn my points on, grab this node right here, move it around, and it will automatically update that model parametrically. So again, if I come over here and change the wall thickness, you can see I can make my walls thicker, thinner. I can just double click on here and type a number in. I can also change their height parametrically. And I can change their justification, which is kind of a little trick on the thing. Right now, these are all interior walls, so I center justified them. But just like Revit, I wanted the ability to left or right justify them also. So I can flip the switch, and you can see the model flipping over there, left, right, or center.
And then what if you want different wall thicknesses?
So I can just take this same cluster, copy it, paste it up here, and type in put a different slider on for a different thickness and apply it to whatever lines I want. So, or I can make a new layer and say thin walls, thick walls, whatever you want. So this isn't final geometry, this is like visualization geometry. When I'm all done with that, let me just delete that real quick. I can actually bake this out and make it real geometry. And now I actually have real walls that are modifiable in the Rhino environment. So up until that point, this stuff is all in Grasshopper only. And I'm just going to undo that real quick. There we go. You can see how it's kind of in red. I can't select these. I can't do anything with them. But I can select that underlying geometry, which is those lines. And I can move them around, and it'll regenerate my walls based on that. So for instance, Andy, just to kind of further go into your question there, I've got interior walls, which have a center justification. They're 6 inches thick. Well, let's say my exterior walls are 8 inches thick. You can see here's my other wall maker, and I'm just going to turn that on. And now I have exterior walls, and this is a different tool because this is a closed polyline versus these open ones, so it takes a little bit of a different script. And just to give you guys an example, I'll go into this script. If I double click it, you can see here's the spaghetti that makes the walls. Okay, this is something that I wrote. This is the script that I wrote to do that. Again, nobody has to see that. All they really need to see is this. So for exterior walls, it's just a little bit of a different tool, but that one, again, you have the ability to go in here, adjust the thickness of the walls, whether they go in or out. And I could even have those have a different height. Right now they're set to have the same height, but I could plug that in and say, make them all the same height together. Have a separate height, sorry, for the exterior walls versus the interior walls. So these little wires are kind of interchangeable here, and so now both heights are going to be linked together. So that's when you start to create those relationships between different things. All right, so this is one example. Let's go ahead and look at another. It works for curved walls, straight walls, it doesn't matter, okay? I'm going to open up a truss here that I made. Okay, so this truss is actually just a line, And so all I have to do in my model, if I have a building model, is draw a line, and then in Grasshopper open up the script that actually goes along with that. And again, I've made a cluster, and you can see this cluster has a lot of inputs, but it all makes sense when you really look at it. There's the depth, the number of divisions, the web diameter, the post diameter, the width of the top and the bottom chord, the number of trusses. There's so many things I can do here. All I'm going to do is right-click on this, set one curve, which is going to be this line, and there's my truss. It just automatically builds a truss. So I don't want to model that truss every time I build a building, right? And so I don't even want to modify it 300 times after this because the structural engineer changes his mind. I just want to go over here and adjust the depth. And you can see it's all stretchy. And I can go over here and change the number of divisions. And just make it look good, make it look right so it represents a truss, right? I'm not building a real truss. My structural engineer is going to do that in Revit Structural. But this gives me a great way to visualize what these things are looking like. One of the cool things that I designed into this is the direction. So we never have just one truss, right? We've always got multiple trusses. So I can go in here and I can set a direction. So I want my trusses to go back this way. So let's turn on ortho and just go back that direction. Okay, I just drew basically a vector, what it's called. And then in Grasshopper, I tell it I want however many trusses I want, and then I can say the distance between them. So you can see these parameters here make it very simple for me to adjust as I go along through the design. And this is a script that I wrote that I can now share with everybody. And if you go into it, yeah, it's a lot of spaghetti, but no one ever has to do that again. It's all been done, and it's just turned into this very simple component right here that lots of people can use. So now I've got 7 trusses. I can go in and change all of their depths together. I can change all of the number of divisions and make it however I want visually, and then I can bake that into my model. And we can render it, we can see it in VR, we can do whatever we want. Let's do a couple more examples here. This is one that, as a designer, something that we do all the time is create storefronts and curtain walls, right? All right, so this is actually pretty much the first Grasshopper script that I ever did. And I'm going to open up my curtain wall generator, which again is just a simple cluster now. But the cool thing about this cluster is that all I have to do is set a curve, or I can set multiple so that they're all the same, and click on that, and it automatically builds a curtain wall. And it's totally parametric. So, for instance, here, you can see my vertical mullions are 2 inches thick. I can thicken them up. I can change their depth. So it's kind of like Revit's curtain wall tool at this point, right? These are all parametric. I can change the count of divisions along the line, and I can change the height. So I can go low or high. And you can see how the horizontal mullions are separate there. And that's because down here, I just set the height of each horizontal mullion that I want. So this creates a great kind of starting point. So for instance, I can go in here and just delete the last one. And that one goes away. So the cool thing about that is now, like visually, really fast, all I had to do was draw a line in Rhino, and now I've got a curtain wall. And architectural element that we use on every single building. And before this, I was drawing mullions, I was copying mullions, I was changing the spacing of them individually, one at a time. And now I can apply this to as many lines as I want inside the model, and I saved a ton of time. So let's go through here and just kind of show you what else it can do. I'm just going to right-click and set a different, here's a straight line, and I can also apply it to a curved line. And yeah, these are really fancy mullions, right? These are like mullions that cannot actually be made, right? Because they're curving. It would be very difficult to make this. But that's why I turned in this smooth faceted toggle, and it automatically breaks it at each one of the segments. So if I go in here and turn on my points, I can actually adjust this curve, and it automatically adjusts everything in that model. And I don't have to rebuild it, because we all know that the design changes over time, right? This is one of those things where I don't want to have to rebuild that model every single time that this happens. So this is a great tool. I found it to be extremely useful, and again, it's just something that you can now download on Echo and use on your projects. All right, so let's go ahead and build. I'll finish up with the last piece here. I want to build my own script to show you guys kind of how easy it is. And these are just again scripts that I've just thought of, that I felt like, okay, if I can't find it out there on the internet and just co-opt it for myself, I can actually just build it myself and then share it with everybody else. So what I'm going to do is I'm going to just basically draw. I'm just going to go in here and let's just call this grid lines. This is an idea that I thought of like last week, and I wanted to make it myself. So let's say we have structural grid, okay? Every building that we do has a structural grid. It would be fantastic if during design we started using structural grids. And so what I'm going to do is just draw some basic structural grid lines. All right, just going to take that. I'm just going to copy it. Actually, let's do an array. I'm not the fastest at this, so let's see. Items, let's do 5. And there we go. Okay, so there's grid lines in that direction. And I'm going to do grid lines in this direction. And let's do it, array it again. And I'll show you what is going to make this so powerful here in a minute. 5 again, and let's just do them at a different module. Okay, so in Grasshopper, I'm just going to make a new document. And what I'm going to do is I'm going to use a node. And what's kind of interesting about Grasshopper is how many nodes there are. You can see here as I kind of scroll through this is kind of the intimidating part. Like, look at that. These are all different batteries that I could use, components, to create things out of. These aren't all the ones that it ships with. I've added quite a bit more just to kind of search through and see what's out there. But that's kind of intimidating, right? Like, what tools are available? What do I even use? And the only way to do it is to actually start using it, all right? But because we have people who work here who know how to use this, I mean, Diego is a fantastic Grasshopper user. There's lots of people who know how to use Grasshopper here. We just don't use it a lot. We just start asking questions. What do we, Google, YouTube. It's amazing, the YouTube videos that are out there. What I'm going to do is I'm going to populate this Grasshopper canvas with components, and we're going to start to wire them together to create a script. And the question is, how does he know which components to use? It's just because I've started working in it. It's the same thing in Dynamo. The more you use it, the more you know what it can do, or you learn what it can do, or you learn another way it can do it, and you become familiar with it. So the first thing I'm going to do is just basically use what's called a geometry pipeline. And this, all I'm using it to do is grab everything on a layer and turn it into a grid line. All right, so I'm going to double click here. I'm going to copy my layer name, and I'm going to paste my layer name in. And I'm going to turn on curves. And you can see how those turn green. That means that Grasshopper is reading those lines. And what I want to do is I want to basically find out where all of those grid lines intersect. And there is a multiple curves. You can see if I just double click and start typing, or if I knew where to look, I can start to find these different components. And what this multiple curves, it basically finds the intersection of multiple curves. And if I hold down, I think is it Control Option and click on it, it actually tells you where to find them. So that's kind of cool. If you ever open up somebody else's script and you hold down Control Alt and click on it, it'll actually tell you where it's located in the Grasshopper interface. So you can start to become familiar with where things are. And so now I'm just going to wire this into here, and you can see it automatically found all those intersections. So we're in the very beginning of building our own custom script now. And so if I click on this, the grid lines turn green. If I click on this, all of those intersections turn green. So I know what that component does because I get that visual feedback. And so we have, for every component, we have inputs. And you can see it's pulled in a bunch of curves, and it has a bunch of outputs. And what I'm really interested in are the points, which are right there. And what I want to do is I want to have it automatically build columns at every grid intersection, right? That's pretty much what we do when we do buildings, right? We do a structural grid, and at every intersection, there's a column, for the most part, all right? So what I'm going to do is I'm going to construct a line. And so I'm just going to type in line and see what different lines I could create. And the one that I want to do is this SDL, which is you can see it says create a line segment defined by start, tangent, and length. So I'll click on that because I want to control how long this line is. And because I'm familiar with conceptual 3D modeling, I know that I can sweep a profile along a path and get a shape out of it. And that's what I'm going to do. I'm going to create a profiled steel column that I'm going to sweep along this line. Okay? So inputs, we have the start point. That's what these points are. So I'm going to plug that into there. And now I have the start point for my lines. The direction, I want the lines to go vertical. So I'm going to type in Z. And I'm going to have them go vertical. Okay, I could have them go any direction I want. And then the length right here, I'm going to just type in and do what's called a slider. So that I can adjust it parametrically. So I'm going to say anywhere from 0 to 10 feet to, let's just say 20 feet is our max. And I get a slider, and I'm going to plug the slider into the Z. Oops, that's the wrong thing, actually. I'm going to plug it into the length. Okay, so now I got a line at every intersection of my grid. All right, so I'll put this over here because this is a parameter I want to control later. I like to kind of keep those over on the left, and I'm going to just rename this column height. All right, and so now I have these lines, and so I click on this, you can see the lines highlight in green. Okay, so we have points, and we have grid lines, and now we have vertical lines, and now all I have to do is put a piece of steel profile on that line. All right, and I know that I have this cool little plugin over here called TT Sweep. Everybody has probably heard of Thornton Tomasetti. It's a structural engineering company. They wrote their own Grasshopper plugin. And what I can do here is I can say the rail right here is going to be the part that I sweep. And check it out. Now I've got columns at every grid line. Now, what's really interesting about this is that these lines are live inside of Rhino, right? And I can adjust the height of those columns. I can make them grow. I can make them shrink. I can do whatever I want to them. But because these lines are live, I can grab a point and I can move this, and all of my columns move with it. So as the design updates over time, I can just go back into the Rhino model and move those. And because this is all parametric with a very simple script, right? We've got, I don't know, 6 components here. That's it. I can update my model just by moving those lines. And if I wanted to, I can actually add in, a column right there, just by crossing those 2 lines. So I can put in custom columns. Let's see, I could grab this. Let's do it with this one. Points on. Let's grab this and just take that intersection away. And now that column goes away, right? Because it's only looking for intersections. And if I right-click on the sweep itself, I can change the shape of that column. I could change the orientation. I could change all kinds of things about it. So I could change a different W shape. And they're all going to update together. Oops, commit. And there they go, all together. So it's really not hard. All you have to do is just start to break down these scripts, and the best place to do that is to start with the ones that I've made or that anybody else has made. Diego's made some, and we contribute them on Echo, and then people can start downloading them and playing with them. We have network licenses available for Rhino, so all you have to do is open it up, get a network license, and start playing with it. And everybody has Dynamo, which you can do very similar stuff in Dynamo on every copy of Revit that we have here. So there's some really fantastic stuff. I'll just open up this, something I was playing with earlier today, so I'm just going to kind of take this to the next level and say columns and grid lines. Let's see. I just have kind of another standard grid layout, and I'm going to open. Okay, so this is just to kind of show you how far you could take this with an extra 30 minutes or so. So here's the same thing I just showed you. I've got columns at grid lines, and you'll notice that like up here, there's no columns at these grid lines, and that's because this isn't on the right layer. So I need to right-click and change the object layer so that it flips over onto there. Oh, actually, you know what it is I need to add that to this group, because right now it's looking for, oh well, I'm not going to worry about that. What I want to show you guys is something else that you can do here. I'm going to enable grid bubbles. Okay, so you can see that I've automatically numbered them in that direction, and I'm going to right-click, go over here, enable this one. So I've got numbers and letters, so it's automatically numbering and labeling those, just like Revit does, but now inside of Rhino. And even go into here, I can turn on some floors, because I created a little floor extruder right here. And what's neat about this is, as I change the column height, the floor goes with it. So again, creating relationships between objects. If I change the floor thickness, make it like 2 feet thick, you can see the tops of the columns actually come down and match the bottom of the floor. So lots of neat little relationships you can build with a little bit of extra time and a little bit more scripting. You can see this is one set of grid lines, this is another set of grid lines, and this is the floors and columns. It's not a lot of code going on inside there. All right, so jumping back to where are the scripts? Okay, so there is a location on the S drive with folders that do have some Dynamo scripts in them, but the more that we leverage the new intranet, we leverage Echo, that's really the place where we want these things to live, because they're searchable. So if you go into Echo, Groups, Computational Design, Files, Code and Script Library, that's where they're located. Now, how are you going to remember that? You're actually just going to type script into the search bar, and they're just going to pop up. So real quick, let's do that. All right. So if I go into Echo, and up here at the top, I just type in script and let it do its thing. You can see right there, Grasshopper scripts, Code and Script Library, Dynamo scripts. There's all kinds of scripts that we already have located in here. Now, does it really matter where they're located when I can search for it like this? Not really. This will evolve over time. We're just getting started. If it makes more sense, if we actually create a specific Dynamo group, we could always move the scripts over there, and it's not going to matter. Like, you're still going to search for it and just find them very easily. But one other thing that I wanted to show you guys here was something that I think is a best practice that I want everybody to do if they are creating scripts, which is like telling people what they do and how they work. Right? Otherwise, we just have a folder full of scripts with names on them, and it's like, what the heck does that thing do? I don't know. So what I wanted to show you here was, I'm going to go into groups. You remember that isolate one that I showed you guys a minute ago? So I created a post in the design tools group, because this is a design tool, right? This is kind of bridging the gap between production and VR, and so it's not really specifically a Revit thing. It's not really specifically a Rhino thing. It's a tools thing, right? So if we go into the posts here, or again, if we just searched, if you know what you're searching for, like isolate, you could find it. But there's a post, and basically it says, what does a script do? And here's what the basic process is, and then I actually do have step-by-step instructions. Ideally, I just want to create a video that takes 2 minutes and shows you the steps on how to do it. And I would like to put that into this post as well. But really, that's something that will make our script library way more usable for people, is to tell them what the scripts actually do, create a link to it. So you can see, like down here, if I get to download this script, and so if I click on this script, click on that link, it takes me right to the file, and I can then download it. So leveraging the power of Echo for us for this kind of thing is huge. It's going to make these way more usable, way more user-friendly, and findable by everybody. Last thing, I guess, is that if you do have questions about scripting, there are definitely like people who know how to do this thing. Les White is learning Dynamo on Revit. He comes from a long background of coding in AutoCAD, and now he's starting to write add-ins for Revit, whether that's through the Revit add-ins section or through Dynamo. We've got Diego, who is a Grasshopper guru. We've got lots of Rhino users. We've got, what I really ask is that you get involved on Echo and start to post ideas, have conversations about this kind of thing, whether it's Dynamo, Grasshopper, computational design, ideas for tools, contribute ideas just by using the ideas module. So like if I go into my computational design group, I can go into ideas and say, I have this idea, I wish somebody would make this tool, and then people can upvote it, downvote it. Somebody who has knowledge on how to do it can take a crack at it, and we can have conversations about it. So again, with Echo, because it's so new, this is a work in progress. If we find better ways to get the information out, we will. And but that's really the place, the repository where this stuff should live, so that we can find it a lot easier than kind of searching folder by folder through the S drive or wherever. So I guess I'll end now with a few minutes of Q&A if anybody has any.
Evan, it's probably in your instructions, but when you download it, do you download it to your project folder or for that specific project, or where do you find it?
If you think other people are going to use it, sure. If you don't, you can download it to your local machine and just run the script, because it doesn't like live in the project. Mm-hmm. It's something you open up, run it, and then close it out. Does that make sense? So, but yeah, if you think other people are going to use it, or if it's something you're going to reuse throughout the life of a project, like the script that I just showed, yeah, just save it, make a folder in your Revit directory called scripts or Dynamo scripts or something, and throw it in there. Again, you can always re-download it off of Echo at any point. It's not like once you download it, it's gone. So.
Any questions online? If anybody has?
Calvin's got a question.
Calvin.
Any
Calvin always
issues
has a
with
question.
downloaded a script that had additional plugins associated?
Yeah. So, for instance, in that wiki that or that post that I just showed, there are in the isolate element script. It does require these two different packages. And so I have a little tag right here. It says, for instructions on finding and installing them, click here. So these are what you search for, but then you can actually go to this wiki that I created that tells you how to install them. And so I have how to install third-party Dynamo packages right on the internet. And it tells you, so here's like some, basic ones that most people would probably, these are the most popular third-party packages out there. Download and install them. Dynamo makes it really easy, actually way easier than Grasshopper for that kind of thing. I'll actually show you that real quick. once you're in Dynamo, there's a thing called a package manager. And inside that package manager, I don't see any other questions on Skype. You can just one button install and you've got it. Here we go. Okay, so I can go up here to the packages section and I can search for a package. And I talk about all this in that wiki, just so you know. And then it takes a minute to sync up because it's looking for all the latest stuff that's been posted. Because Dynamo is open source, there's tons of people creating third-party packages, and you can see all the different ones. If I start scrolling through them here, like there's just tons and tons and tons. And again, how do you know what even to look for? And that's why in that wiki I give kind of some basic ones that you probably want to start with. But what I like to do is sort by downloads. And then we can see which ones most people are using. And these are almost always the ones that you kind of need. And once you find it, you just click this arrow and it installs it. That's it. Once you've done that, you've got it installed. You don't have to do anything else. So back to this wiki here, instructions. I talk about the packages pull down, search for a package, and so this if something changes in Dynamo, this wiki will get updated by us to reflect any new changes that they may do or may not. So that's why I chose to do this as a wiki. Any other questions? Have you guys got your gears turning on maybe things you could automate? I mean, Dynamo, you can automate anything inside of Revit. You could have it automatically build sheets or renumber sheets or renumber rooms, or there's so many things. I mean, lots of people at HMC have talked about what it can do. I actually wanted to start to show you guys like how easy it is to actually do it instead of just looking at screenshots of what other people have done. All right, so it's a new challenge. It's something that you can do and not be afraid to break. I mean, if you break it, big deal. It's just code, right? We can fix it. We can delete things. We can add new things. I really wanted to take away any kind of intimidation factor. Of course, learning anything new takes some investment, right? But it's worth it because we can shave hundreds of hours off of the stuff that we do in Revit every year with this kind of stuff. Hundreds of hours, right? And that's really the goal, is to have fun getting more efficient. Like, let's build tools. So start thinking about it and post ideas in Computational Design Group. Think about things that you want as a Revit user, and we'll figure out ways to build it, all right? So I hope you guys are excited about this. It's really fun, and I encourage you all to play with it.